Sometimes a group of atoms can covalently bond together to form something that's like a molecule, but it's not neutral like a molecule. It has a charge. These things are called polyatomic ions. The word part poly just means many, and so these are really many-atomed ions. So they're covalently bonded particles that have a charge. Here are a few examples that are fairly common. Nitrate is NO3 1 minus. That's nitrate. You'll see that one a lot. Sulfate is SO4 2 minus. And there's phosphate, PO4 3 minus. You might have heard of that one before. Another one is called ammonium, and that's NH4, and it actually has a 1 plus charge. And then another one, this is not quite as common, but I just want to throw this in here to show that they can be actually many-atomed. This is acetate, C2H3O2 with a 1 minus charge is acetate, which is in vinegar. Polyatomic ions, of course, will form ionic compounds because they have a charge and they're attracted to cations or anions, whatever has the opposite charge. These compounds, just like ones made from monatomic ions, have neutral charge. And just like with monatomic ions, you can find the formula by doing a charge swap, swapping charges like with monatomic ions. So here's an example. If a potassium ion, just a group 1 monatomic ion, bonds with nitrate, I look at the charges, K plus and NO3 1 minus, and I would charge swap. They're equal and opposite charges, so I'm not going to put any subscripts except for the 3 that's already there as part of nitrate. So KNO3 would be the formula for that compound. Another example, sodium bonding with sulfate. Sodium is 1 plus. Sulfate, SO4 2 minus, has a 2 minus charge. So I charge swap. 2 goes after sodium, 1 goes after sulfate, but we don't write 1s. And so the formula for this compound is Na2SO4. Notice that the 4 doesn't disappear and turn into a 1. That 4 in sulfate is always going to be there. It's part of sulfate structure. Calcium bonding with phosphate. Calcium is a 2 plus charge. Phosphate, PO4, has a 3 minus charge. So I charge swap. So this 3 is going to go down here, and this 2 is going to go down here. So when I write this, I might write Ca3, PO4, 2. Now there's a little bit of confusion that's caused here by the fact that this looks like 3 calciums, 1 phosphorus, and 42 oxygens, and we know that's really not true. That 2 is supposed to refer to the whole polyatomic ion. So parentheses eliminate the confusion by putting parentheses around the polyatomic ion. Then we know that the subscript refers to the entire ion, not just the last element that was there. Another example, ammonium bonds to sulfate. So ammonium is NH4 1 plus, sulfate is SO4 2 minus. Here we have 2 polyatomic ions bonding to each other. This works the same way as always, by charge swap. So NH4, I'm going to put parentheses around, and then I'm going to make it subscript 2, because that was the charge on the sulfate. And the sulfate is going to get a 1 subscript, but we don't write 1s. So there's the formula of the compound. Barium bonds with acetate. Barium is 2 plus. Acetate, C2H3O2 1 minus. When I charge swap, I'm going to have parentheses around my acetate. Barium doesn't get a subscript because the charge on acetate is 1. So there's my formula right there. You try one. Potassium ion bonding with sulfite, which is SO3 2 minus. Stop the video and write this, and I'll bring you the answer. Okay, here's your answer. When I write these things side by side, K has a 1 plus charge, and the 2 from the sulfite gets swapped down, and that becomes the subscript on potassium. Potassium's charge is 1, so there's no subscript written on sulfite, and so it's K2SO3. Try another one. Aluminum with nitrate. Here's your answer. Again, write them side by side, cation first, so Al3 plus, NO2 1 minus goes after that. Subscript on aluminum is going to be 1 because that's the charge on nitrite. The subscript on nitrite is going to be 3 because that's the charge on aluminum. Because it's a polyatomic ion, I enclose it with parentheses first, and then I write my 3. There's your formula. One more. Lithium with phosphite. Lithium, 1 plus. Phosphite, PO3, 3 minus. When I charge swap, lithium gets a 3. Phosphite doesn't get any subscript, so it's just Li3PO3.